And today's webinar is about SolidWorks Load Case Manager and Design Study inside simulation. We are going to try out the Load Case Manager feature, and later we are going to try the Design Study feature. I'll be telling the difference between those two features, Load Case Manager and Design Study. And I have realized not many people are using Load Case Manager when it comes to simulation, but it is a very useful tool. So once you know how to use it, it will be useful for your design scenarios to study and analyze. Okay. So let me move on into the topics. Okay, before we go into the topics, these are the simulation packages we have inside SolidWorks. There are 3 tiers of simulation. One is Standard, Pro, and Premium. So you can see the dark gray color box. Those are the options which are available inside Simulation Standard. And then you have the second tier, which is Professional, which includes Standard plus those features available inside the light gray box. And then the larger box, which is the Premium, which includes everything. Okay, now today I'm going to show about Load Case Manager and Design Study. Design Study is available in the standard packages and also in the CAD Premium package, but the Load Case Manager is available on Pro and Premium simulation licenses. So if you don't have a Simulation Professional or if you don't have a Simulation Premium license, you can't use Load Case Manager, and also you can't do optimization. Optimization is an advanced option which is available inside Design Study. I'll talk about that later. Okay. Okay, and for example, if you want to decide which simulation package you want to get, you can look at these options in here. If you are doing lots of thermal analysis or if you have to do lots of frequency analysis, you can choose Professional package. And in your designs, if you are using lots of nonlinear materials like plastics, rubbers, if you want to study the response of a structure due to the permanent deformation or after permanent deformation, you can get Simulation Premium license. If you have a project requirements where you have to do only like a static and fatigue analysis, you can choose standard packages. Okay. Okay. Now, so these are the topics we are going to see today: Load Case Manager and Design Study in simulation. I'll briefly touch about Design Study, but I'll explain more on Load Case Manager. I'll show the case study on Load Case Manager. Okay. And before I show the case studies, I'll explain about Load Case Manager and when we can use Load Case Manager, what is the purpose of using Load Case Manager and how it works. And then I'll explain about Design Study, how to set up a Design Study, what is the purpose of Design Study, what is the difference between Load Case Manager and Design Study. And also I'll show 2 examples, one for Load Case and another example for Design Study. Okay, so these are the topics we are going to see. Okay, the first thing is Load Case Manager. If any of you are using SolidWorks 2014 or previous versions, Load Case Manager is not available before 2015. So Load Case Manager is a new feature which is available from SolidWorks 2015 version onwards. Okay, and as I said before, this feature is available only for Simulation Professional and Simulation Premium license users. So if you have a standard or SolidWorks Premium, you can't use Load Case Manager. And the next thing is this Load Case Manager supports only linear static analysis. So if you want to perform a dynamic analysis, if you want to perform a frequency analysis, you can't use a Load Case Manager. Okay, it's limited. And what is the purpose of using Load Case Manager? What it can do? By using Load Case Manager, we can set up different multiple loading conditions, and it has an interface, something like a table. So once you set up all your fixtures and your loads inside your simulation study, these details will be transferred onto those tables. From the table, you can easily manage. For example, I don't want to use a fixture and see how my design is responding. You can toggle off the fixture, and then I don't want to use all the loads. I want to use like 2 loads, or I want to include only the gravitational effect and see my design response. You can do that by using Load Case Manager. This load case manager helps you to create multiple loading scenarios by toggle on and off the fixture, by changing the loading condition, create a new different load combination. You can also create like a loading combination. Let's say I have a combination 1 and 2. I want to combine 1 and 2 together, and I want to create a third combination. You can do that by using load case manager. Okay? How we can start the load case manager is, first thing is you have to set up a static analysis. That is your initial condition. Okay? And then you can create a load case manager and define primary load case. By using primary load case, you can create multiple scenarios. Like I said before, you can change the fixture definition, you can change the load magnitude, you can suppress the load, you can change or give equations for the load, and then you can create combinations. You can further linearize and combine the primary load case by using the secondary combination. I'll show that later. Okay. So this is the use of load case manager. By using load case manager, you can analyze your design with multiple load combinations. Okay. So what are the types of loads supported in load case manager? Almost all types of loads are supported in the load case manager. As you can see, pressure, force, torque, even the remote load and bearing loads are supported inside the load case manager. So it's not limited only to a specific loading condition. You can use you can manage all different loading conditions through there. Not only the loads. If you want to define a predefined displacement, for example, I can use reference geometry, set the displacement, limit the displacement in a direction. I can manage the displacement value inside load case manager also. I can manage the fixture definitions. I can give different fixture definitions and test my design. Okay. And this is an example. I just wanted to highlight here how the primary load case looks and how the secondary combination looks like. Okay. Primary load case can be created from the initial condition. You can see the below screenshot, which is like a table, and you can see the first row in the table, the second row, first and second row, which are grayed out. Those are the initial conditions, which is defined inside our simulation static study. Okay, and we can use that initial condition and we can create different combinations or different scenarios from the primary load cases. As you can see from the table, there are two load cases under primary condition, dead load and life load. In the dead load, I have suppressed all force values or let's say working load conditions. I have suppressed it, force 6, 7 and force 8, which are suppressed. And I included only gravity in vertical direction, vertical downward direction. So that is my dead load condition. In case if you want to test your design in different gravitational direction, you can also use multiple direction and change the value in that table, and you can run the study for the scenario and check. For example, I want to give 2 times gravitational force in X direction and test my design. And I can create a load case in the primary load and set the gravitational value 2 times 9.81 in X direction, and you do the calculation, it will give you the results. And then you can see the second row under primary load case, which is the life load. I'm using all fixtures in both cases, but in life load, if you notice, I have enabled, I'm using only the working load condition. I neglected the gravitational effect. So basically I created 2 load conditions. One is the dead load, which includes the self weight of the design. Another one is the life load, which includes only the working load condition of my design. So I want to check the response of the structure on these 2 conditions. It's not only limited to this primary load case. In load case manager, you can use equations and create combinations by further linearizing the primary load conditions, and you can combine it. So as you can see the top right corner, the screenshot, you can edit the equations. You can create load combinations. That is your secondary load combination. Okay. If you see that image in here, in the secondary load combinations, I have created an equation 2 times dead load plus 2 times life load. Basically, I'm combining the primary load cases, dead load and life load, and I'm multiplying by 2. Okay. For this combination, what is my structural response? How my response of the design is changing? How it is affecting my stress value? How it is affecting the deformation value? That's what I want to find out. Okay. So these kind of combinations, these kind of equations, and you can combine the load case by using this load case manager. And also by using primary load condition, you can define different load cases, and you can test your design for multiple loading scenarios. That is the main purpose of load cases. So let's say you have a design and you want to test it for multiple design scenarios, and you want to combine the design scenarios or loading scenarios and see the results. This is the tool you can use, load case manager. Okay, I'll show an example, and you can ask me a question like, how do I track the results? You can use a sensor. There is a useful tool inside SolidWorks, sensors. You can create a sensor for displacement, for stress value, for factor of safety value. Add the sensor into the load case manager. So that sensor will track the results for the displacement or stress, whatever value we defined inside the sensor. Okay. So let me move on into the example. I'll open up a SolidWorks. So this is the sensor I was talking about. You can see it from here. The sensors can be added from the screenshots. You can see here, I added a displacement sensor. Okay. And before I show the SolidWorks, these are the steps I have to follow for the load case manager. One is the static study. First step is to create the static study. Inside the static analysis or the static study, define all your fixtures, loads, contacts, and mesh. Everything must be defined inside the static study. Once you define the static study, create a load case manager. Start up the load case manager. Define your primary load case by managing your fixture conditions and by managing your loading condition. You can vary your loading condition and you can create your primary load case. Next step is you can create a combinations by using the secondary load case. You can combine your primary load cases by adding some equations. Okay, and then you can analyze the results for multiple combinations, and you can track the results through the sensor. These are the steps I'm going to show you. I'll show you how to set up the load case manager, and once you run the load case manager, or once you calculate all the results from the load case manager, I'll show you how you can interpret the results. Interpreting the results through the load case manager is very flexible, and it instantly changes the results when you change the load cases. I'll show that also. Okay. Let me minimize this. I'll open up SolidWorks, which I already opened it. I'm going to use this example. I hope you can see the screen, the SolidWorks screen. I'm going to use this example scaffolding. It's an assembly, scaffolding assembly. And I have lots of tubes which I want to treat as a beam element. And some components I want to treat as a shell element. And for the demonstration purpose, I want to simplify this assembly by removing the small gussets. Okay, just to save time, I'm going to take out those gussets and create the simulation setup. Okay, this is an assembly. I have to do lots of contact sets, contact definitions, material definitions, and element definitions. So to simplify and to save time, I have predefined the setup already. Let me activate the predefined setup. I have a completed study already, because if I run this assembly, it takes around 10 minutes to solve in my PC. So I already completed it. Okay. And you can see here, this is my predefined setup. I'm going to show you how you can create the load case manager, how you can set up this load case manager. Okay, so I'll start up a new study. I'll show by creating a new study. I'm creating a new study from here, from the simulation tab. I'm going to give the name as load case example. And this load case manager supports only static analysis. I'm choosing the static study. A new static analysis is created. You can see here, this is my static analysis, and I have the path, and there is a join group folder because some paths are created by using weldments, so it will be treated as a beams automatically. Okay, And also you can see I have this wooden plate. I don't want to find any results on this wooden plate. I can assume that to be a rigid part, and I'm not worried about the deformation or stress on the wooden plate. I can take out the wooden plate from the simulation study by excluding it from the analysis. And I'm going to use the same material, steel, one of the steel. I don't want to manually apply for all the components. Okay. Instead, I don't want to define the element type manually for all the components. Instead, I'm going to copy and paste it, or I can simply drag and drop. As you can see, I'm activating the predefined study in here, the load case, the first simulation study. Once I activate it, I can copy and paste it. Okay. So in this setup, you can notice I have a green color tick mark in the parts folder. Means all the definition is defined for the parts. Definitions like a material definition, element definition. Okay. So I'm going to right click and I can copy it. So you can see I have an option to copy this material property and the element definition, mesh element definition, or I can hold the parts folder and I'm dragging it and dropping it onto the study 2. Just drop it on top of the study 2. It's loading now. As you can see here, my wooden plate is automatically excluded from the second setup or the second simulation study. There is no wooden plate. And also, if you notice this parts folder, I have a green color tick mark, meaning all the material definition and the element definition is transferred from the previous setup to the new setup. Okay. So in case if you want to copy any material properties, you can simply right click and copy the folder and paste it into your new study. You can see here, my beam element is transferred. These are the icons for the beam element, and this is an icon for the solid element. And this plate I'm treating as a solid, and some of the beams, for example, these tubes are treated as a beam element. Okay, now after I copy this material definition and element definition, I'm going to create a joint group. Since I have a beams inside the setup, I have to create a joint. So you can right click on the joint group, edit definition. It's very simple to create joints inside SolidWorks when it comes to beams. You can simply choose all and click calculate. Joints will be calculated for your beams in the simulation study. Okay. You can also choose to manually calculate the joints between selected beam members. You can use the other option called select, and you can manually choose 2 beams and create joints also. Okay. Right now I'm using the automatic way of creating joints between all members. Okay. In the next step, I have to define the contact condition, contact sets. Okay, I'll tell you the contact condition. These tubes are welded onto this plate, so I can create a bonded contact condition. And then most of the beams are welded. Again, I can create a bonded condition between 2 beams, between a face and the beam element. And in here, I have this bracket. This bracket can translate on the tube surface, on this surface over here. I mean, this bracket can be moving on this surface. It will be sliding on this surface. So I have to define no penetration conditions between the bracket and then the tubes or the beams. So I need to create lots of contact condition. Instead of creating it again, I'm going to reuse the contact condition which is defined inside the study 1. So I'm going to again activate the study 1, copy the contact definition. You can also choose to copy your contact conditions. Okay, so I'm activating it. And you can move your cursor to the connections folder, right click on the connections, you can copy it, or you can choose to drag and drop the connections to the study 2. Okay, these things you might have known already, so I don't want to spend more time on showing how to create contact sets. So I'm trying to save time in here. Okay, let me show you the contact sets which are transferred. As you can see here, more than 10 contact sets are transferred from the predefined setup. And this is an icon which shows bonded condition is defined between beams and the face. So I have selected 4 beam members, the red color beam members. These members are bonded onto these faces of the plate in here. So I selected these 2 faces as the target, the source is the beam. And in the same way, I created a bounded conditions for the other side between the beam and the plate. And then no penetration condition is defined between this bracket and then the tube over here. The red color face can slide on this purple surface. So I have defined no penetration contact conditions between this bracket and then the tubes. I have created around more than 5 no penetration conditions between the bracket and the tubes in the assembly. Okay, and then the rest of them are the bonded conditions between the beam and solid elements. Okay, so all the contact sets are defined. The next step is I have to define the fixtures. Like I mentioned in the slide, this load case manager can be used to manage your fixture definition also. If I define like 4 fixtures, I can toggle on and off selected fixtures inside the load case manager. I'll show that later. First thing is I have to define the fixture definition. So again, I'm going to copy and paste the fixture definition from the predefined setup. So I'm going into the study 1. It takes time to load that. So I'm going into the study 1 and I'm going to drag and drop the fixture definition. So this is the fixture which I already defined. So let me drag and drop it into the study 2, which is copying. After I copy it, I'll show you how the fixture is defined. And as you can see here, the legs are fixed to the ground. So I define the fixed geometry on these 4 legs. You can see here. The bottom faces of those vertical legs are fixed and constrained. And the next thing is I have defined use reference geometry on this bracket. So I have selected these 10 red color points. I have selected the vertex point of this bracket, as you can see from my screen. This red color point is the vertex which is selected inside this inside the fixture definition, and I have constrained the Z direction or the normal direction to the front plane. You can see the arrow. This direction is constrained. It should not be moving in that direction. So I constrained that displacement for that bracket. Okay, all the brackets are constrained in the normal direction to the front plane. So 2 definitions of fixtures are defined inside this simulation setup. The next thing is the loading condition. I'm going to apply the vertical downward force on this top platform on all these faces. I'm going to give a downward force of 3,500 Newton and another downward force on this beam, 1,650 Newton. That is my second force, our second loading condition. The third loading condition is the gravitational effect. I want to include the cell's weight or the gravitational effect. So I'm going to add gravity. And fourth loading condition is mainly to stabilize the model. I have this vertical beams. I need to fix it in the vertical direction. I'm going to make use of force to constrain that vertical displacement of this beam. So again, the loads are applied in the predefined setup. I'll copy it and then edit and show you how the load is defined. It's loading the predefined study. Now, because the mesh in that setup is a bit dense, that's why it takes time to load. So I'm going to copy this external loads. Okay, I have to define the external loads. So I'll show you how to define the external loads. It's not created in the predefined study. I have to create the external loads. I'll show you some examples for the external loads, and then I'll move on into the load case manager setup. First thing is I must define the external loads in the static analysis. Okay, so I'm going to create force. I'll be selecting all these faces. Let me define those force on these faces, the top face of the platform, which is subjected to the downward force of 3,500 Newton. Okay. And since I'm in the first definition, I want to highlight something to you all. I'm not sure whether you know about that. So you can give 3,500 and you can choose to define the value per item, or you can choose to define the value in total. Okay. So I'm going to define this. Yeah, I have accidentally selected some vertex or edge. So let me delete that edge. And I can define the value in total. So total force is 3,500 Newton. It's not 3,500 on each of these faces. The total is 3,500 Newton. Can create the total force. And my second downward force is on this structure, the small beam over here, the rectangular tube. I'm selecting that. I'm giving the values. I'm adding up 1,650 Newton only onto that face. So that is my second loading condition. My third loading condition is the gravitational effect. I can right click on the external loads and enable gravity. Make sure to check the direction of the gravitational force and the value, 9.81, the standard value. So I'm going to define that gravitational effect or gravitational load. And one more thing, like I mentioned, I have done few trials and these beams are not constrained properly. So to make it constrained, I'm going to use some external load. You can also use fixture, it's up to you. There are lots of ways you can constrain it. I'm going to show you how to define fixtures on the joints of the beam. So you can see here, there is an option to select joint. I'm selecting the joint. I pick the joint 1 and joint 2, 3, and another joint in here. And reference plane, I'll be using the top plane. I want to give a force of 1 Newton in the top plane. The force must be acting downward. But if I see the arrow, it's pointing up, so I need to choose downward force. So I'm going to reverse the direction. Okay, now I have specified all loading definitions and all fixture definition I need for the setup. And I can copy the mesh from the predefined study. I need to refine the mesh. I need to apply mesh control on these rectangular tubes because those are treated as a solid element. Those are not a shell element. I mean these rectangular tubes in here, the platform, the top platform, those are solid elements. I have to refine the mesh. I need to apply mesh control. And also for these small vertical tubes, I have to apply mesh control. I need to increase the number of elements for those beams. So which I have already done that, so I'm going to show that later. Okay, after you define the fixture definition and loading definition, context sets, and mesh, you can create your load case manager. Now, let me show you this load case manager interface. To access the load case manager, you can right click on the top level of the simulation tree, okay, and you can find load case manager in here. I'm going to create this load case manager. So it will add a new tab here at the bottom. It will create a new interface similar to the design study. This is my load case manager interface. You have a load case manager tree which transfers all the definitions from the simulation tree. Basically this is a simulation tree, okay, and this is the load case manager table. And you can see in this table I have 2 rows. Those are my definition in the simulation setup. We call it as an initial condition. So by using this load case manager, I can create multiple combinations by varying the initial condition. So I'm going to vary the initial condition by creating 2 different load cases. First thing is I'm going to add the primary load case. You can click on this plus button. It will add the primary load case. That is my load case 1. I'm going to rename that load case as dead load. You can see here I created a new load case called dead load, and all the fixture definition and the loading definition are transferred onto the primary load case dead load. If I don't want to use the fixed one, I can uncheck that. Meaning for this study, or let's say for this case, dead load, fixed geometry will not be used if I untick this option. And I have another fixture defined inside my simulation setup, which is my reference geometry. Let's say that particular reference geometry it can move up to 2 mm. It is constrained after 2 mm, or it is limited to move only up to 2 mm. Okay, so in that case, I want to test it for that condition 2 mm limit. So I can give 2 mm in here. I can choose to change the values, and I can test for different loading scenarios, different fixture scenarios. But I'm not going to change that. I'll keep that reference geometry as 2, but you have a freedom to change that value. The next thing is dead load means I want to study the structural response of the scaffolding for the self-weight. What happens to my structure for the self-weight condition? Okay, what is the stress and deformation due to the self-weight? So I want to include only the gravitational force. So I'm moving into this column gravity, normal to the plane, and there is a drop-down arrow. I'm clicking on the drop-down arrow and selecting this value 9.8. That is 1 times of your gravitational force. If you want to change the value to 2 times of the gravitational effect or 10 times of the gravitational effect, you can simply type 10 minus 9.8, which is the downward gravitational force. Okay. In this case, I want to study my design for 1g, 1 time of your gravitational force. So I can leave that value as minus 9.81. If you want to add the gravity in other 2 directions, you have an option to add it in other 2 directions from the setup in here. Okay, you can include multiple gravitational effect also. Okay, but I'm not going to do that. Okay, and the next case, primary load case, is the working loading condition, or we call it as a life load. So I'm going to give the value or name as life load. In the life load, I have to use the same 2 fixtures, but the loading condition, I'm going to unsuppress this force 1, vertical downward force I'm using in the case 2. And the second vertical downward force 1650, again I'm using that value in the study 2 or case 2. And I don't want to include this gravity. So the gravity in all 3 directions, I'm going to leave it as suppressed. Okay, but I want to include this downward force, so I'm going to give minus 1 in here. So as you can see, with the help of the load case manager, I'm trying to study my assembly in 2 other different loading conditions without creating 2 different setups. I'm doing it within one interface. With the help of the load case manager table, I can easily manage and vary the fixture combinations and load combination. I can change it, vary that, and I can run and see the performance due to that load condition. Okay, now after you add all your primary load cases, if you want to further add combinations, means you have an option to add load case combination. As you can see the option here, there is an option for load case combination. That is our secondary load case. Okay, basically it will do the calculation for your initial load case and then primary load cases, and then it will come on to the combinations and it performs the calculation. I'm going to add the combination now. So I'll click here to add combination. As you can see, it automatically gives me a suggestion, dead load plus life load. You can combine that. Let's say I don't want to combine the dead load plus life load. I can edit this equation. I can take out this life load, but I want to see the dead load when I multiply the value by 2. So I'm giving the combination as 2 times of the dead load. So you can see here, it's 2 times of the dead load values. Okay, I want to add another combination. In this case, I'm going to add the scale factor for both primary load cases. Scale factor is 2. So I'm going to multiply 2 times of dead load, and also at the same time, I want to add the 2 primary load cases with this scale factor of 2. So I'm adding the dead load plus life load with the scale factor of 2. So when my design is going to work on this loading combination, 2 times of dead load plus 2 times of life load, what is my stress value and what is my deformation value? I can find out with the help of load case manager. So by using the load case manager, the advantage is I can combine multiple loading scenarios. I don't have to manually calculate any magnitude of the forces. I can combine it with an equation, and it will do the calculation based on this combination, and it will give you the results. That is the advantage of this load case manager. it allows you to combine your loading scenarios. Okay, so you can see here I have created two combinations. Maybe I can give this name as base combination. Okay, you can rename it, and if you want to edit the equation, you can edit the equation anytime. And what is the result you're trying to track? You need to add sensor for the result you're trying to find, or the results which you want to track. So you can click on this plus icon and add sensor. I'm going to add the sensor for simulation data because I'm trying to create a sensor for a simulation study. And sensor type is stress value, one measures stress. You can choose to have different values: stress, strain, displacement, safety factor, thermal analysis. Okay. And unit system is megapascal or Newton per mm square. I want to find out the maximum one measure stress. I'm choosing model max. Once you add the sensor, it will be loaded into your load case manager. You can see here, stress 1 is added into your load case manager. Okay, I want to add another sensor for displacement, so I'm going to add sensor, simulation data, and I'm going to choose displacement now. And I want to track resultant displacement, so I'm choosing resultant displacement in mm, maximum displacement. So you can see here, I created two sensors for the two results which I'm interested in finding out. One is the stress, another one is the displacement, which are added into this track results from the load case manager. Okay, I have defined all the setup for my load case. I have a static study, I have defined primary load case which I want to test, I have a combination which I'm interested in studying, and I have added the sensor for the results I want to find. The next step is you can simply click on run and you can find out the results for different load cases. Once the study is completed, you will get the results in this tab, or it will activate this result view tab. Right now it's red because I didn't run the study. Okay, it's not run yet. After you run the study, it will be activated. You can view the results or interpret the results from this tab. And before you run, let's say, okay, I don't want to run a selected combination. You have this option in here. You can choose to untick the combination which you don't want to solve. I don't want to solve this combination one. You can untick this and click OK. Means it will run only the 3 selected combinations. Okay, I don't want to report. I don't want to generate the report. I'll cancel that. Okay. Now I have selected to run dead load, live load, and the second combination base. I'm not going to run this combination one. Okay. So once you define all the setup, you can simply click on run and study, run and calculate it, and then you can view the results. I have already completed the setup. If I run this setup, it will take around 10 minutes to solve. I don't want to wait for 10 minutes until it solves the study. So instead, I'm going to open up the completed file and show you how you can interpret the results from the load case manager, how you can check the results for dead load, how you can find out the results for combination. Let me show that. Give me a second. I'll close this file. I hope you can see my screen. So I'm opening the completed file. This is the completed file with all the results. Okay, before you create the load case manager, if you run from the simulation tree, let's say if I run from the simulation tree, it will run with all this definition in the simulation setup. Okay, so this is giving you the results for initial condition with my 3 vertical forces, vertical downward force and the gravitational effect. As you can see, for this condition, this is my stress value. If I include all live load and gravitational effect, I'm getting the maximum stress value as 93.2 megapascal. But my another requirement is what is the stress value for dead load or for the self weight, and where is my maximum stress? I need to find that. And what is the structural response only if I use the working loading condition without the self weight? That is another requirement. And what if I combine both self weight plus the working load condition, and if I multiply the scale factor of 2, what is the value for that combination? I need to find that. That's why I created the load case manager. Okay. So as you can see, for the initial condition with all the fixtures and forces included in the setup, I'm getting the maximum stress of 93.2. and my displacement as it will be around 13. Yeah, it's around 13.54. You can see here my maximum displacement is on the platform, somewhere at the middle of the platform in here. Okay, that is my maximum displacement. If I include all my fixture, both fixed geometry and reference geometry, zero translation in z direction on the bracket, and these forces, all the forces are included including the gravity. Okay. Okay, now let me show you the results from the load case manager. After you run, how can you check the results of your load case combination? You can right click on the load case manager in your simulation tree, view or edit definition, and then it will open up this table, load case manager table. You can see the load case view where I define the definitions for the primary load and secondary load, and then I can see here my result view is active. Previously it was not active before I run. After you run and solve it, the result view will be active. You can select the result view. So once I pick the result view, it will show the results under the sensors which I created. You can see here, these are the displacement value. I created a sensor for the resultant displacement maximum. For the dead load, my displacement is only 2.2 mm. For the live load or the live load, my displacement is 12 mm. For the combination, my displacement increases to 27.05 mm. So this is what I can find. So let's say, okay, I added the sensor only for displacement. I didn't add the sensor for the stress value. And how come I'm not saying the color plot in the model? I want to see the color plot as well as the chart as well as the node where the maximum displacement is exerted. Okay, so in that case, in your load case manager, you have this tree, the load case manager tree or simulation tree. You can activate the stress or displacement for which you want to see the color contour and plot. If you want to hide the force values, you can hide it from here. Let me hide it to make it more nice. Okay, I'm going to hide the fixture definition. Okay, I'm just hiding the fixtures and forces. I can also hide the joints if I need. And now let's see the color plot for the stress value. Okay, I'm going to activate the stress. When I double click and activate the stress value, it's loading the color plot. As you can see from my screen, this is my stress value in the model and stress color plot in the model. It shows the stress only for solid and shell elements, not for the beam elements. That's why the beam element results are hidden. You can change the plot to beams if you want to see the results on the beams. You can notice my stress is maximum on this point, 82.8 megapascal. You can ask me how come the stress value is different. Before I activate the load case manager, I showed the stress value. It was 93 point something, but now the stress value is 82.8. What is this value? For what combination or for what case it is showing this value? Right now the live load is active. This 82.8 is the value for the live load or the live load. Okay, now I want to change the results for the dead load. How can I check that? You can instantly change the result. It will instantly update the result once you select the load case from the manager. So once I pick the dead load, so I already selected the dead load, it is trying to update the results. You can see my maximum stress value. For the self weight, my response is totally different. I am getting the maximum stress value on the other opposite end. Okay, on the bracket in here, my maximum stress is only 11.2 for the dead load conditions. Okay, this is how you can interpret the results easily inside load case manager by simply toggle between the cases which you want to see the result, and the color plot and chart will be automatically updated. Okay, okay, now let's try displacement now. So I'm activating the displacement. I want to make sure this displacement in the table is matching the displacement on the color chart and the color contour, and where is the maximum displacement. I want to find that. Okay, now you can see after I activate the displacement plot, you can notice from here, for the dead load condition, my maximum displacement is 2.21, and it is matching to the sensor I created. I created a sensor for the maximum displacement. The sensor value it shows 2.2, which is correct. And let me change it to a live load. I'll show you the displacement for the live load. So it is trying to update now. It takes some time, okay, because of the density of the mesh. I'm using a dense mesh in this setup. And you can see here my maximum displacement for the live load is 12.17. Okay, how about the combination? I haven't showed the combination yet. So let me activate the combination now. So when I activate the combination, you can see here, it will update the chart. You can see the right side of my interface. You can see the URES displacement chart. It is updated as well as the color contour. The maximum value is updated to 27.05 something. Okay, so it is very simple and easy to interpret the results or change and check the results inside Load Case Manager. And this Load Case Manager helps you to save time if you want to study your design with multiple loading scenarios. If you want to combine your loading scenarios, when you combine and if your design is going to work on that combination, how it is going to respond, you can do that within the Load Case Manager. Okay, so this is the use of Load Case Manager. This is how you can check the results, and this is how you can add the definitions. Okay, and that's all about this Load Case Manager. That's all about this example. And later, if you have any questions in this Load Case Manager, you can let me know through the chat window. I'll help you to answer. I'm going back into the slide. I'm going to show you the next example, design study. Okay, because I'm going to trying to explain the difference between Load Case Manager and design study in this case. Okay, let me go back to the slide. Okay, can you all? I think you can all see my slide. Okay, I'll maximize that. Okay, now in the second part of this webinar, we are going to see this design study. I'll give an introduction about the design study. Okay, normally I would say if you're creating a new design, it is always better to use design study and optimization and check how can you improve your design performance, how can you get a better design, how can you reduce the weight of your design, at the same time achieve the safety limit, design limit. Okay, maintain the design within the safety limit. Okay, this is where the design study comes into play. Okay, by using design study, I can create multiple design scenarios, not the loading scenarios. In the previous example, I explained and show about Load Case Manager, where we can use the Load Case Manager to study our design for different loading conditions, loading combinations. You can create equations and create loading combinations. But design study helps you to analyze for different design scenarios, and for the design study, all you have to do is to choose your variable. So if this is going to be a variable, how my design is going to respond when the variable changes. Okay, so your variables can be your load, it can be your geometry dimension, it can be your material property. Okay, simple example I'm giving. I have created a design. I want to test which material is the best material I can use for my design. I'm worried about the design safety or factor of safety. I want to maintain the design safety within the limit. At the same time, I want to maintain the stress within a certain limit and displacement within a certain limit. I know the design limit value for the stress and displacement and safety factor. So those are my constraints. If you know the variable and if you know the constraint, let's say in this case my material is the variable, I can define different material property. Let's say I can test my design for steel, I can test my design for composites, I can test my design for, let's say, plastics or some other fiber materials. Okay, so which material is giving me better performance, which material is lighter, and how can I reduce the weight? I can achieve it by using design study. Okay, so this is the purpose of using design study. Suggesting you, if you haven't used Load Case Manager or design study, please try to use it more, and you can save plenty of time. You don't have to do trial and error, manually change the value, run it again and check it. You don't have to do trial and error. This will help you to save lots of time. Okay, and you can reduce the time to market also. Okay, like these are the things you have to know for the design study and the optimization. As you can see the graphics on your right hand side in the slide, I have that wheel, alloy wheel, and when you perform the design study with optimization, it will try to reduce the thickness of the alloy, and it will try to see whether when it changes the thickness, whether it can maintain the design constraint, whether it is safe within that limit. It will automatically do that and give you a thickness value. Okay, so this is another example. I put an animation in this slide, and by using optimization and design study, you can easily find burst alternative from that variable. Once you choose the variable, out of those variables, what is the best value I can find? I can easily find it in lesser time. Okay, that's why we can reduce time to market, and at the same time you can reduce the cost and weight. When you reduce the weight, definitely you can reduce the cost. You can choose a better material property, and you can improve the product quality. Okay, and a simple example, like I said, is if you know the design limit, which is your constraint, my stress, I need to maintain the stress within 100 megapascal. You can set that as your constraint. I'm allowed to change the thickness of the alloy, change the thickness between the range. This optimization will change the thickness value in that range. At the same time, maintain the stress below 100 and give you the best suitable value for you. Okay, that is the optimization and design study. Let me show an example on that. So this is the assembly example I'm going to use. It's a very simple example. I have that gray color plate which is made of nylon. Okay, I'm going to use nylon for that plate, and I have this link connection, okay, which is pin support, and I have the red color rod, and there is a distance between two red color rods. My concern is this distance. I have found that when I use this distance 400 mm, I found the displacement or deformation is more than my design limit. So I want to find out the best alternative value for that gap, 400 mm. What is the value I can use? Okay, I know some selected values, the variables I can define for that 400 mm. So I'm going to set that value as my variable inside my design study and find out when I reduce the gap or when I increase the gap, which one is giving better or lesser deformation value, less stress value, which one is giving the best deformation and best stress value. That's what I want to find out. Okay, so let me show that from the design, and I'm not going to use an assembly. Before I show you the setup, I'll explain a few more things. I'm going to assume this rod is a rigid rod. I'm not worried about any deformation or stress on that red color rod because it's rigid. Okay, and also I'm not worried about the pins and the contact forces between the rod and the pin connections. I'm not worried about any contact forces. I'm going to take out all those parts. I'm going to use only that gray color plate, meaning only that part file. Okay, I'm trying to simplify the simulation setup. Okay, and also since it is pinned, the rotational degree of freedom is allowed. So I'm going to define hinge connection for that hole. Okay, so let me show you how to define this setup. I'll go inside the SolidWorks. Let me minimize this file. So this is the plate I'm going to use. As you can see here, this is the distance. The 400 mm is the distance between the two link connection or the rod connection. I want to change this gap and see how this gap is affecting the performance. Can I use a lesser value for this distance? Or if I increase the distance, what is the deformation, how it is affecting my stress and deformation? Okay, and this plate looks symmetrical and all my boundary condition looks symmetrical. So I'm going to make use of symmetry boundary condition inside simulation. I'm further simplifying the simulation setup by using symmetry. I have created a cut extrude feature. I'm going to suppress it. So you can see here, I suppressed it. I created a cut. Okay, I'm using only 1/4 of the model. As you can see from the feature, I'm using only 1/4. Okay. Okay, now let me create a new static analysis. Again, for the design study, you need to have a reference static study. It can be a non-linear analysis also. Okay, I'm going to give the name of this study as 100G, meaning I'm going to use 100 times of the cell's weight, 100 times of the gravitational force. Okay, That's why I'm giving the name 100G. That is my loading condition. And material is automatically transferred from the CAD model, SolidWorks Nylon from the material database. It is transferred, and I'm going to define the fixture. So like I said, it is a pin connection and rotational degree of freedom is allowed. So I'm going to give hinge connection in here. So I selected hinge fixture and choose the cylindrical face of the hole and setting the fixture in there. The next thing is, since I'm using only half of the model, or let's say quarter of the model, I have to specify this symmetry boundary condition. So I'm selecting the symmetry. I'm picking these two faces. As you can see the preview, it shows the symmetrical boundary condition preview. The model is symmetry. And my loading condition, as I said before, my load is the gravitational effect, and it's not in the Y direction, it is in the Z direction. So I'm going to change the reference plane for the gravity to front plane, and it looks fine. Now the gravity is pointing down, and the value is 10 times of 9.81. So I'm going to type in 981 meter per second square, 10 times of G. Okay. Okay. Now I define the loading condition. Then I can create mesh. Let's say I'm going to use it's a simple model. I'm going to use a curvature-based solid element high quality. And how can I define the dimension 400, this gap as the variable? How can I create design study? How can I create multiple scenarios? Let me show you how to create multiple design scenarios. So when you go to the Evaluate tab, you can find out the design study. And it will add a new tab at the bottom, Design Study 1. You can rename the study if you want. And I'm not going to do optimization. I'll just show you Design Study. I'm going to add parameter. Your variable can be your dimension. It can be your material property. You can test it for different material property and see which material is giving better performance. Okay, so you can find that. But in this example, my variable is this gap. When I change the gap between the two link or two rods, how the deformation is affected, I want to find that. So I selected this dimension 400. You can see here it says already selected. I'm going to give the name distance. Okay, I can give a name of a gap. So distance is added into the variable. I can change the variable. I can tell the design study to do the calculation to change the variable based on range with step or by giving discrete values. I'm going to give discrete values now. You can't use range for the design study. You can use the range only for optimization study. So if you have simulation professional, you have another advanced option called optimization. When you choose range, you don't need to give the step. So if I set a range between 200 to 600, it will do the calculation between the range. It will give you that minute value. For example, if it finds 355.16 is the best optimal value, means it will find that 355.16. That is the optimization study. But in design study, we can only use range with step. You can give the step increment. Let's say I want to increase by 100 mm, or you can give discrete value. So these are the values I'm allowed to use. For example, 475 mm, 425 mm, 375 mm, 325 mm, 275 mm, 225, and 175, 125, and 75, and 25. Sorry, it's 25. So what is this discrete value? Basically, I'm telling this software to change this dimension to 475, do the calculation, change to 425, do another calculation, 375 and do another calculation, and so on. Okay, so it will change to these defined values in this table. Okay, and it will do the calculation for those tables and give you the results. So from that result, you can compare and see which value is giving better performance or better deformation and stress value. That's what I'm going to find now. So what is your constraint? Okay, my constraint, everyone will have their design limit. Okay, every design will have its own limit. So for the constraint, I'm going to use simulation data against stress value, megapascal, maximum stress. I want to monitor the maximum stress. In design study, you can only monitor it. You can't control this constraints. But in optimization, you can control the constraints. I want to maintain it more than or less than the selected value. You can do that in optimization, not in design study. Design study, you can monitor it and compare the results manually. Optimization, it will do the comparison for you. It will maintain the value within the limit, and it will give you the best design performance optimal value. So let me add another sensor. Let's say I'm going to add another sensor for the displacement, resultant displacement, and in mm maximum displacement, I want to only monitor it from this study static 100G. So once you set up your conditions, your variables and your constraints, you can simply click on run and you can get the result. Again, I have completed the study to save time. It takes around 4 minutes to run this. So this is the completed setup I have, which I ran before. So you can see here, I have this setup and similar setup which I showed before. I have this design study. These are the values I set, discrete values inside the design study. These are the values I wanted to track. And once you solve it, you will get this result view tab, and you can find all scenarios in the design study. So which gap or which distance is giving me better stress and deformation value? If I notice 475 mm is giving deformation of 5 mm and stress value of 14 megapascal, and let's say my design limit is I need to maintain the displacement less than 1 mm and also stress value less than 5 mm. That is my design constraint. So I'm trying to find out the value to meet that design limit. Displacement less than 1, stress value less than 5 mm. So when I compare these values, definitely 475 is out of the scope, and also 425, and also 375. 325 is close to my requirement, and I'm checking the 275, and you can see here 275 mm, this gap is giving me displacement of 0.3, stress value less than 5 mm, which is my design requirement. It is meeting that requirement. Let me compare the other values also. I can take 225, it is out of the requirement, and also 175 and other 3 values. Okay, so with the help of design study, I have found that if I use this gap as 275 mm, I can maintain the displacement less than 1, and at the same time I can maintain the stress value less than 5 mm. So let's say if I don't know how to do the design study, if I never use the design study, I have to manually change the dimension, create a new study, rerun it and check the results. But with the help of the design study, we can set our variables, and later you can compare the results from the variables, and you can choose which variable or value is better for my design, or which value is meeting my design requirement. I can find that. Also, like I mentioned, you have an advanced option called optimization. By using optimization, you can set your design limit, actual design limit. Let's say I want to maintain this displacement maximum less than 1 mm. I can give 1 mm. I want to maintain the stress value less than 100 megapascal, or let's say in this case 5 megapascal. I can give 5. And what is your goal? My goal is to reduce the weight of the design. So I'm trying to reduce the weight. I'm trying to make the design lighter. At the same time, I'm trying to meet my design requirement. Okay, so give me the best value for this condition. So I have given the goal as minimize mass. Constraints are displacement and stress, maintain less than these values. And this is the value you can change. So you can change this value. Let's say I can give a range instead of the discrete value. I can give the range as, let's say, 200 to 500. Change these values, do the calculation, give me the best value. It will do the calculation for you. It will maintain the constraints for you. It will reduce the weight, and it will give you the best value. That is the optimization analysis. I'm not going to run it. I'm just highlighting it to you. Okay, this optimization is available only for simulation professional and simulation premium licenses. So if you have a simulation standard or SolidWorks premium, you will not have optimization, but still you have design study. You can do the design study, but you have to manually do the comparison. At the same time, you have to choose the discrete value. These are the values I'm allowed to use, like I defined in the discrete value table. You can't use the range option in the design study without the optimization. Okay, this is about design study. Now you can ask me, let me create another design study and show you the difference. Now you can ask me a question, what is the difference between design study and load case manager? In design study, we can change the geometry dimension and we can create a scenario for that. We can change the material property. You can see here, I can choose material. You can see material is added in here. So I can give some name and create it. So if I want to test the same design for different material property, I can add multiple property. Let's say one of the material is nylon, and I'm going to add another material. I want to use aluminum alloy, and I'm going to check my stress and displacement. If I use nylon and if I use aluminum for my design, which one is giving me better performance? So I can do this calculation. Now this dimension is fixed, but the material property is changing. Okay, so as you can see from here, if I use aluminum alloy, my displacement is reduced further, but the stress value is more than 5 megapascal, which is not meeting my design requirements. Like this, you can do the comparison easily with the help of design study. And the load case manager, you can use load case manager to study or analyze your design for different load combinations. Okay, and different fixture combinations. Not only load combination, fixture and load combination, you can vary that and you can combine the combinations. Okay, that is the load case manager and design study inside SolidWorks simulation. Okay, so that's all. That's the end of this case studies and